So you've just caught a whiff of something burning. You run to the stove and see that your bacon has burst into flame. Thinking fast, you grab the fire extinguisher from your closet and spray the growing fire before it gets out of control. Luckily, it was the right type of fire extinguisher. Different fuels create different types of fires, and each one needs to be extinguished using a specific strategy. Depending on the chemistry between the fire and the extinguishing agent, the fire might go out, or it could actually spread. Fire comes from a chemical combustion reaction between oxygen and fuel. The fuel can be anything from wood to metal to grease. When it's heated to a very high temperature, what's called the ignition temperature, and when there's oxygen around, a fire starts. Then a chain reaction will add heat to the fire, keeping it going. Oxygen, fuel, heat, and that chemical chain reaction make up what's known as the fire tetrahedron, and a fire extinguisher works by removing at least one of these elements. Before fire extinguishers, people used water to put out fires because they knew that it worked. Water removes a crucial part of the fire tetrahedron, heat. But depending on the intensity of the fire and what's fueling it, water isn't always enough to put a fire out. That's why many countries have fire class systems, which categorize fires according to what they're fueled by. Fire extinguishers, meanwhile, are categorized based on which of these fires they can put out. In the US, the 5 main types of fires are A, B, C, D, and K. A Class A fire is one fueled by common materials like wood, paper, cloth, plastic, or rubber. And a Class A fire extinguisher can put out a Class A fire. The most common type of Class A extinguisher just has water in it. To put out Class A fires, water is all you really need. A Class B fire can be fueled by flammable liquids like gasoline or paint, or by flammable gases like propane. A water-based fire extinguisher can't be used on a Class B fire because the stream will just spread around the fuel and the fire. But any fire extinguisher that can block the fire's oxygen supply works well. Class C fires are caused by energized electrical equipment like appliances or motors. Water is not a good way to put out an electrical fire, since the electricity can be conducted through the water and shock anyone standing in a puddle. Class A, Class D, and Class K extinguishers all contain water-based suppressants, making them both ineffective and dangerous for Class C fires. Carbon dioxide extinguishers, on the other hand, are perfect for both Class B and C fires, since they replace the oxygen surrounding the flame with non-conductive CO2, effectively suffocating the fire without spreading it. Also, when the carbon dioxide leaves the extinguisher, it uses up some energy to expand, lowering its temperature. This super chilly discharge helps reduce the fire's heat. The most common fire extinguisher used in households today is the multi-purpose dry chemical extinguisher, which can put out Class A, B, and C fires. ABC extinguishers often contain monoammonium phosphate, a material that's also commonly used in fertilizer. Monoammonium phosphate leaves a blanket of non-flammable dust on the fire's fuel that separates it from the surrounding oxygen, smothering the flames. But even a dry chemical extinguisher can't put out a Class D fire, which is fueled by combustible metals like magnesium, titanium, sodium, or potassium. Machine shops that manufacture metal parts, like nuts and bolts, are at the highest risk of Class D fires, largely because their work produces so-called metal sawdust, shavings that turn into fantastic kindling when they're hit by a stray welding spark. Combusting metal reacts violently with the materials found in dry chemical extinguishers and releases toxic gas into the air. Plus, an ABC extinguisher's high-pressure spray can blow the metal dust and shavings around and potentially spread the fire. So if there's metal on fire, you're really gonna want a Class D extinguisher. They're also called dry powder extinguishers, and they spray at a lower pressure so they don't spread metal particles around. And they contain graphite and sodium chloride, which don't react with burning metals. Instead, they work both by absorbing the heat of the fire and by separating the fuel from the oxygen. The last type of fire is Class K. Class K fires feed off of grease, oil, and fat. They're the kind of fires that normally happen in restaurant kitchens. The acid in many oils and fats prevents dry chemicals from creating a foam blanket to smother the fire. And water molecules quickly spread out when they hit hot oil, creating a steamy, fiery explosion. Plus, water can splash oil onto flaming stove burners, which could ignite and spread the fire even more. Instead, Class K wet chemical fire extinguishers contain alkaline compounds, or basic compounds. These combine with the acid in the cooking oils and fats to create a soapy layer on the surface of the oils, which extinguishes the fire. If it's hard to keep track of which type of fire is which, there's a clever mnemonic. Class A leaves ash, Class B boils, Class C has a current, Class D has dense materials, and Class K happens in the kitchen. Remember that, and you'll know exactly which fire extinguisher to use to save your bacon. Thanks for watching this episode of SciShow, which was brought to you by our patrons on Patreon.